You know, when we think about protecting a football player's brain, the first thing that comes to mind is the helmet, right? It's that hard outer shell. But what if the best armor isn't something you wear at all, but something you actually build from the inside out? Today, we're diving into two totally different ideas about brain safety, the external armor versus internal strength. Let's get into it.
So, let me ask you this. What's the biggest threat to a player's brain? We all picture that one massive highlight reel collision, but it turns out the latest science is pointing somewhere else entirely. The real danger isn't always the one big hit you see, it's the hundreds you don't.
Exactly. The real focus now is on what scientists call subconcussive impacts. These are all those smaller hits in practice, in drills, during the game that don't cause a full-blown concussion. They're invisible. A player feels fine afterwards. But over a whole season, all that little damage, it really adds up.
So, here's how we're going to break this all down. First, we're going to really dig into this whole unseen injury problem. Then, we'll look at an external solution, those guardian caps you see on helmets. After that, we'll get into how scientists can even measure this kind of microscopic damage. Then we'll flip the script and look at an internal armor approach, using a nutrient called DHA. And finally, we'll put it all together to see what these two sides of protection really mean for the future.
All right, first up, let's really understand this unseen injury. This is the damage that's happening below the surface, hit after hit, day after day. And the scary part is, it's happening even when a player feels totally fine and passes every single concussion test on the sideline. And this quote from a major study, wow, it really says it all. Using some pretty advanced brain imaging, scientists found actual measurable changes in players' brains after just one season of high school football. They saw injury to the axons. That's basically the microscopic wiring that lets your brain cells talk to each other. And here's the kicker. This was in players who were never diagnosed with a concussion. The damage is happening whether we see it or not.
And the sheer volume of these hits is just staggering. We're talking about over 1,000 of these little impacts for some guys in just one season. Now think about that. Multiply it over a 4-year college career or maybe a decade in the NFL. You can start to see how this quiet, invisible damage suddenly becomes a massive concern.
So, this brings us to our first line of defense, the external armor. I mean, it's a logical first step, right? If the problem is impacts, let's just soften the blow. And that's where the guardian cap comes in, that big padded shell you've probably seen covering helmets during team practices. And the hype around these things just exploded back in 2022. The NFL came out with this stunning number. They saw a 50% drop in concussions among players who were wearing them in the preseason. I mean, get this, a 50% reduction. On the surface, that looks like a total game changer. Problem solved, right?
Well, not so fast. There was a pretty big catch. That 50% number, it was based on the number of reported concussions, not on a scientific study that was actually measuring the force of every single hit on the field. So the real question for researchers was, forget what's being reported, what does the hard data actually say?
The expectation was super simple. More padding equals softer hits. But when the first really big on-field study came out, using these high-tech mouthguards that measure every single impact, the finding was a complete shock. The guardian caps didn't reduce the force or the frequency of the hits at all. Not one bit.
So what on earth was going on? Well, the data from over 7,500 impacts showed something really weird. Players were getting hit less on the face mask, but they were getting hit 151% more on the back of the helmet. The leading theory for this is something called risk compensation. Because players felt safer with the extra padding, they might have subconsciously changed how they played, maybe leading with their heads more. The big takeaway is that adding padding doesn't just change physics, it changes human psychology too.
Okay, so if the external armor isn't actually stopping the force, then we desperately need a new way to see the damage it's causing inside the brain. This really pushed scientists to find some kind of biological signal, like a check engine light for the brain.
And they found one. It's called neurofilament light, or NFL for short. Now, this is a protein that basically makes up the internal skeleton of your nerve fibers, those axons we talked about. When those fibers get stretched or damaged from an impact, little bits of NFL leak out into the bloodstream. So by measuring the levels of NFL in a player's blood, scientists get a direct signal. It's literally a check engine light for brain stress.
So being able to measure this unseen damage with a tool like NFL, well, that opened up a whole new strategy. If we can't stop the force from the outside, maybe we can make the brain itself more resilient from the inside. This brings us to this really cool idea of internal armor.
And this internal armor is built with something called DHA, which is a type of omega-3 fatty acid. Think of it like this. If your brain cells are like tiny water balloons, DHA is a key ingredient that makes the rubber more flexible and stretchy, less likely to get damaged or pop when it's under pressure. The whole theory is that having more of this essential building block helps your brain cells literally withstand the physical stress of all those hits.
And this isn't just some wacky theory. The evidence has been building for years. Back in 2016, a huge study at TCU was the first to show that giving football players DHA seemed to have a protective effect on their brains. Then, in 2021, an even bigger study, this time across multiple universities, confirmed those exact same findings, adding even more weight to the idea.
And this chart right here is the proof. It shows what happened to that check engine light protein, NFL, over a full season. Look at the control group on the left, the players not taking DHA. Their NFL levels shot way up. That's a clear sign of all that accumulating brain stress. But now look at the group that was taking DHA. Their levels barely moved. The biological evidence of trauma was way down.
The main point here, and it's consistent across all the research, is this. The hits were still happening. The players were still getting knocked around. But the brains of the players taking DHA showed far less biological evidence of damage. Their internal armor was actually working, protecting the brain from the inside against that constant barrage of impacts.
So, let's bring this all home. It's time to put our two very different approaches, that external armor and the internal armor, right next to each other and see where we stand.
This table really just lays it all out, nice and clear. On one side, you have the Guardian Cap, our external armor. The method was a padded shell, and the key finding? It didn't reduce impact force, but it did change where players got hit. On the other side, you have DHA supplementation, our internal armor. The method was nutrition, and its key finding? It dramatically blunted the rise in NFL, that direct marker of damage to the brain's wiring.
So what's the real bottom line here? Well, the science is making it pretty clear that brain safety isn't an either-or kind of problem. It's not just about better helmets or better nutrition. The real future of protecting these players is probably a holistic approach, combining the best possible external gear with proven strategies to build a stronger, more resilient brain from the inside out.
Which leaves us with this one big question to think about. Is the ultimate solution for keeping players safe something that's just worn on the head, or is it also something that has to be built, cell by cell, from within? The science seems to be telling us that the answer is both. And that right there is a huge shift in how we think about keeping athletes safe on the field.